Hi everyone, we are going to present our presentation. Our team name is ST team and we are three in our members, Santosh, Shiva, Tuktaboy. And the topic is decision tree and random forest classification. First we go through our slide and then we'll go our notebook. What is the decision tree and random forest classification? There is some definition. Decision tree classification is predicting discrete category of target. Example, predicting type of customer, given feature. Random forest classification is, as its name suggests, is a collection of decision tree. There is example of decision tree with the real data. A decision tree look like a flowchart or inverted tree. It grows from root to leaf, but in an upside down manner. We can easily interpret the decision making prediction process of decision tree due to its structure. It works as if then is statement. This picture describes the retail data of customer will redeem coupon or not. There is the rule set model decision tree. If the loyal customer, then it goes to the next node. Household income, it check the household income is greater than equal to 150K, then go to the shopping node. Same like this. And the later last, redeem the coupon. There is terminology. There is the many nodes. The starting node is called as a root node. It is split further by making a decision based on the some iteration into what are called as an internal node. The internal nodes that split further are called as parent nodes, and the nodes forms out of parent node are called as child nodes. The nodes that do not split further are called as leaf nodes. There is a best binary partitioning. There is a two regression tree and classification tree. There is some definition. Audition tree can be classification tree or regression tree based upon the type or target variable. The class in case of classification tree is based upon the majority prediction in the leaf nodes. In case of regression, the final predicted value is based upon the average value in the leaf nodes. The other part Dr. Boy will tell about the other slide.
Okay, thank you. Tree depths. So tree depths is a measure of how many splits a tree can make before coming to prediction. So this process could be continued further with more splitting until tree is as poor as possible. So deeper we can allow our tree to grow and the more complex our model will become. And you can see the tree deep tree and how it's becoming okay complex tree. So when we'll have more splits, it captures more information about the data. This is one of the root cause overfitting in decision tree because our model will fit perfectly for the training data. So we can see the two predictor decision boundaries. So we took the iris flower data. So classification problem. So you can see that classification of the iris iris data like tree uh, decision tree decision trees here you can see and you can see spell length and weights of the how is how is modeling and we are here training our data. So and you see the how is classification tree is going on. Okay, it's going it's growing and so we can see the here left side our diagram and right side our tree. This tree is going how is going on. Okay, so minimizing overfitting or stopping like it's when we limit tree depth it's like when we stop when we stop splitting so after certain depths so and the data will so I mean few data and few and the less accurate prediction will be like it affect not good for the data, less data, and less prediction. So minimizing overfitting pruning. So you can see the formula here and how its dip tree is overfitted. It seems like this. So penalize dips to generalize. Yeah, we can see the formulas here. So next slide I will give this answers. Thank you very much.
Talking about the problem with single decision tree. Single burn tree are poor predictor. We can see here this is not a good shape. Single deep trees are noisy. Bagging, we can see the image here. Sample record with replacement. Sampling is the process of selecting a subset of item from a vast collection of the items. On other hand, bootstrap is sampling with replacement. It means a data point in a drawn sample can reappear in future drawn sample as well. It can be comes here and here also. And bootstrap aggregating, this is the crowd we can see here, and this is the prediction error. It is reducing the prediction error here. And about the random forest is identified as a collection of decision tree. Each tree estimates a classification, and this is called a vote. Ideally, we consider each vote from every tree and choose the most voted classification, majority voting. Random forest follow the same bagging process as the decision tree, but each time a split is to be performed. To search for the split variable is limited to a random subset of M of the P attributes. We can see here image. Uh, this is a different decision tree here, and we are taking uh, majority voting from the different decision tree, and we will going to make a final class here uh, using the majority voting. And bagging versus random forest. Bagging introduce randomness into the rows. It will take the data only from the rows, and in random forest introduce randomness into the rows and columns of the data. It will take data from rows and column both sides. So, and this is random forest out of bag. When the number of data is small, OBB is less reliable. When it will increase, the more efficient than k-fold CP. When the number of trees are about 3x the number needed for the random forest to stabilize. And a random forest tuning. Random forest provides good out of the performance, but there are a few parameters we can tune to increase performance. Those kind of parameter will increase the random forest performance, like number of trees, metric, node size, sampling scheme, split rules, and so on. Random forest strength and weakness. Uh, Talking about the strengths, competitive performance remarkably good out of the box, very little tuning required, built-in validation set, typically does not overfit, and so on. In the other hand, weaknesses, although accurate, often cannot compete with the accuracy advanced boosting algorithm, can become slow on large dataset. It can be slow in large dataset and less interpretable. Yes, thank you. Hello all. Welcome to our presentation, which is related with machine learning. And this part is related with a decision tree. And we are going to show decision tree in Jupyter Notebook. Here we just import some libraries which is needed for this one, and this one is our data. We are just trying to read data where you guys can find this data from here, Kaggle. This is related with the hard digits data set. There is 13 columns here, and you can go through if you want. And we just load the data. This is CSV data, and we just try to get the shape of data. There is 1025 rows and 14 column with the target. We just made a target column here, and we just try to get first 5 rows of our data. Uh, Here in our target column, 0, it means no hard digits, and if there is 1, then that guy has a hard digits. And this one, we are getting last 5 rows, and this is information about our data here, integer, integer, float. And for this study, we have to get without null value. We can check our null, is there any null value in our data set. We can see there is no null value in our data set. So in our target value, there is like 526 people are hard digits, they have a hard digits, and 499 people they don't have a hard digits there. And we just try to show our data in bar graph using plot. So 526 in 1 we can see here, and 499 in 1, which is less than the 1. And we just try to train our data. In X side, we are including all rows, but not including the target column there. In Y, we are including all rows and only one column, the target column here. And for this one, we just need to import the train test split, and we are using the test size is 20%, which is preferred size. And we just try to count the values uh, for target column. One means who has heart disease. In our data, 51% people has a heart disease and 48% people has no heart disease. For the decision tree classifier, we just import some decision tree classifier and trees, and decision tree regressor also. And we just try to create a decision tree function here, and we make a data model with a decision tree classifier, and we just try to fit our data in Xtrain and Ytrain. And we just try to predict the score. We are getting one score here, which is very good. We are getting one score because we are using the same data set. That's why we are getting one score. In real other project, other cases, it will be less than 1. So this one is the predict data, predict of X test, and this is the value counts 50%. This is value counts of Y test that was from Xtrain, and 50% of people they have a heart disease, and 49% they don't have a heart disease. And this one is a shape of training. We are just getting the shape of Xtrain and Ytrain, 822 rows and 13 column, and in Ytrain we are only using 820 rows. And we just try to fitting the models in Xtrain and Ytrains, and checking the validation score here, which is 1, which is the very good. I already tell you about 1 because we are getting 1 because we are using the same data set. Yes.
Here is our notebook random forest classification some coding part and this little bit definition as well here. The first we just importing the our libraries in Panda as PD, NumPy as NP, Seaborn as SNS, Matplotlib as .myplot as PLT, and we just loading the data. We get the data from the Kaggle set and the df variable with the df variable we load the data and try to get data shape, and then there is some oh, rows and columns, and then top 5 data from the dataset. We take the top 5 dataset from the head, and then from the some bottom 5 from the bottom df tail, and some information of the data types here. We get some null data or non-null data, integer types, and little bit we describe the data here. And then we get the statics value here, like a count, mean, standard deviation, mean value, percentages, maximum, minimums, so on. Next, we try to check the missing values from our dataset, if there is a null value or not, and that's the other is null. And then try to check any missing value from our dataset, and then it shows all the zero, so it means there's no any non value. And then here we just describe the target of data. The in result, one has hot digits and zero has no hot digits. So we get here the value here who has 526 hot digits and 499 has no hot digits. And then we describe it, so it's visualization with the plot using Seaborn library and count target variable count plots. And here also we can see the data of the date of the hot digits and not hot digits of the persons, and this value is like a same value of on this plot, and the other part which tell about other guys. Thank you.
Okay, and random forest as an ensemble of tree. Here we try to split the data set in x and y, a y-axis, and okay, and x-axis we all rows except last column, and we all rows and only last column we took, and yeah, here we see the result, the shape like, and how is row and column. So generally we train our data through the sklearn model. So we select the sklearn model to test and train our data. So here we see that how the random forest classification, and we use Criterion Gini, max steps 8 and minimum sample speed 10. So random state 5 line 9. So we can see that here how we took for train, and then we start train, and you can see that how is feature important features, how is important data is. So you can see that 0.08, and is and the maximum is 0.14, and the lower is 0.008. And as a column name, okay, index is, you can see the edge, and the sex speed as control. So you can see the features here. And okay, we predict X star, and if there is one has heart disease, if there is a zero, so no heart disease. So from the test we can see that how is column and how is array and 122 and 128. It's like and so and here we can see the accuracy score is almost good, and almost same with the classification record. Okay, almost same, and it's good. So and here we can see that how is feature importance. Okay, and here is which one is important and which one is less. So you can see the importance is relevance and feature importance. Okay, thank you very much.